Hello everybody, myself Nikhil Shantanu Zoman, and today I'm going to tell you about how to design a solar rooftop PV system and how to do their payback period analysis. Before that, let us understand why solar PV system is important nowadays. First, it is a renewable source of energy. Second, it reduces electricity bill. Third, it is environment friendly as it does not produce any greenhouse gases. Fourth, it reduces our dependency on the power grid. Fifth, low maintenance. Sixth, government support, which means while we are installing the solar PV system, government gave us subsidies. Now let us see the block diagram of solar PV system. So basically this is the block diagram of solar PV system. In that there is a PV array, inverter, electrical counter, utility grid. So basically sorry to say that but there is a mistake in this block diagram. So basically there are two blocks which are missing in this block diagram. First block is missing between PV array and inverter which is nothing but a DCDB, while the another block is missing between electrical counter and utility grid which is nothing but a ACDB. Now let us see how to design a solar PV system. So for that we have to collect electricity data of last 12 months. After collecting the electricity data of last 12 months, then we have to calculate the yearly consumption. To calculate the yearly consumption, we have to add all last 12 month electricity consumption. After calculating yearly consumption, then we have to calculate average monthly consumption. For that, we have to divide yearly consumption by 10. I have considered 10 months as the system is not 100% efficient. After calculating the average monthly consumption, then we have to calculate the daily consumption. To calculate daily consumption, we have to divide monthly consumption by 30. So after calculating the daily consumption, then we have to calculate the required kilowatt of panel. To calculate the required kilowatt of panel, so first we have to understand the insolation for particular site. So basically for Nasik, 1 kilowatt system generates 4.5 unit per day. So to calculate the required kilowatt of panel, we have to divide daily consumption for divide so we have to divide daily consumption by 4.5. So basically I got 0.91 kilowatt. So I have considered 1 kilowatt system by considering future load also. So after that, we have to calculate the number of panel required. To calculate the number of panel required, we have to divide system power by module power. I have considered the module power of 520 watt. So I require two panels for 1 kilowatt PV system. So I have considered the solar panel of Vari company, and these are the technical specification of that panel. So now let us calculate the inverter size. To calculate the inverter size, we have to multiply the total plant capacity, PV plant capacity into 1.25. So I got 1.25 kilowatt. So I have considered 2 kilowatt inverter by considering losses and future expansion. And these are the technical specification of the inverter that I have considered, which is of Polycap company. Now let us see how to calculate payback period. To calculate the payback period, we have to divide the total solar system cost by annual saving from solar system. So for 1 kilowatt solar PV system, the cost of without subsidy is 95,000 and with subsidy is 55,000. To calculate the annual electricity generation, we have to multiply system size into average sun per day hours into 365 into PR ratio. The typically PR ratio is 0.75. After calculating the average electricity generation, then we have to calculate annual saving. To calculate the annual saving, we have to multiply the unit generated per year into electricity rate. As you can see, I have calculated the annual saving. After that, we have to calculate the payback period by considering the subsidy. After calculating the payback period, as you can see, I have 3.6 year payback period. So basically, this means that after installing the solar PV system, I will get all my money after 3.6 years, which I have invested in my solar PV system. Thank you.